All right. Hello, everyone. Thanks for joining us today. So, I'm Rohit Dandamudi. I'm one of the engineering interns here at Fermion, and I will walk you through the second challenge and kind of code the solution. Okay, let's get started. The second challenge of Summer of Spin is the travel itinerary challenge. So basically, we are trying to build a travel planner kind of thing out of keywords that we'll give in a prompt to the LLM model. So the keywords we are looking for is destination, duration of the trip, number of people involved, and certain activities that they might want to do. And after that, we'll kind of generate a prompt. This is a sample prompt here, and at the end we kind of expect a response from the application to see the generated itinerary, and also be able to store it in a key value store that Fermion has to kind of retrieve it later. So these are the two helpful links here, and yeah, let's get started. All right. So I opened the Summer of Spin repository locally. Sorry. Yeah. And the easiest way to get started with a Spin application is use one of our Spin templates. For that, you will need our Spin CLI. So we use the command Spin. Let's see. Let's move into the solution to directory, and then we have to use the Spin new command. And here we can use the HTTP Rust application. I will be coding it in Rust, but you can use any other languages, C, C++. And since this is a simple web application, we're using the HTTP template. And the name of the application will be Travel Planner, uh, typos, and help plan travel, travel plan. Okay. And the endpoint that we're looking for here, as shown in the description of the challenge, is plan my trip. So we have to use this, or we can even edit this later, but just be easier if you include this now. And any other wildcard on top of plan my trip route will be used. So now I think we have a directory in solution tool. Let's see. So there you go. There is a travel planner directory, and let's just open this in a new window here. Okay, perfect. All right, let's see what we have. We have a simple boilerplate code to just say hello Fermion. It's simple HTTP response, and we have a cargo.toml file for Rust application and spin.toml file. This is what we will need to kind of add few things on top of it. So for this application, we'll need two of the Fermion features. One is the Fermion AI inferencing. You can use it locally, but I suggest to use Fermion Cloud GPUs, which are much faster than like running these models locally. So use Fermion Cloud GPU and also Fermion Key Value Store. So if we look at the documentation, we can just add AI models. Since we're using a Llama Chat 2, we can just add it here. And for the key value store, I think we will go with the, let me see the documentation. If I'm looking at right, there's another screen here. So excuse me. And yeah, for key value store, we should add another, and we'll be using the default key value store. You can create a new one as well, but I'm just using the default key value store that Fermion has. So you can check this out here. So it's a spin help, and it has all the things that you would need. All right, going ahead. We also need few things in cargo, like in Rust ecosystem. For example, few dependencies like Zerde. Oh, easiest way is to add to terminal. So cargo add Zerde. Cargo. Let's see. And Zerde JSON. Cargo add. And also I need a So we have to generate a unique tag here, and for that I saw create called random string just to generate a random string out of character set that we give, and I'll be using that to generate a tag. So it's a random string. So these are the three kind of external dependencies that we're using on top of already existing dependencies. So we do this. Let's reload the window and see if these are added. Let's not save this. Okay, perfect. I think these are added. And for third, let's just add the feature version and features. Okay. Okay, perfect. So now that this is there, interesting. Why isn't this working? Sorry. So yeah, to get started, the first thing I would like to do is kind of get the request object. So to do that, we just have to get the string for it. So we have to access the request body. Let's see. Add body. Oh, actually, we can just. Oh, first thing we have to put it in the structure that we need. That is this format. So I will build a small struct here. Struct prompt input, and here we'll need the destination to the string, duration, all are basically strings here because we are adding things to the prompt. And people and activities is a array or a vector of string again. So this will kind of help capture different things. All right. Let's also use the divide feature here. Save the lines and debug. Okay. So we'll use the set 80 serial lines. Okay. All right. Let's get the. Honestly, at this point, we can directly get the prompt input from the request body. So we will say, let's see, the JSON of from slice, and we can use request body here to get the body, and we'll use unwrap. Just not really good practice, but just to save some time. For now, okay, we have the prompt input. So now we'll kind of generate the prompt itself. So we'll use format. So like complete prompt equal to format. And let's use the. Okay. Let's use the example prompt that we gave here. So let's take this. So we'll need a string literal here. Use string duration. Let's see if this prompt actually works. uh, this was just an example. I actually never tested this before, so let's see. Okay, we got the string, literal, and then just gotta give the variables, not input dot destination, duration equal to duration. What else? People equal to and activities equal to input dot activities. Kind of, we have to join all the activities here. So, comma. Okay, I think this will kind of get all the uh, variables into the prompt, and we'll have a proper prompt. And now we have to kind of call the inferencing AI inferencing model, uh, the Llama 2 chat model to kind of get the itinerary out of it. So let generated, let's see, are we getting, yeah, we have to get the itinerary and infer. So we are using the Llama 2 chat model, and the prompt given is the complete prompt that we have. And let's unwrap it and take the text out of it. Okay, perfect. So this should probably generate the model. So uh, one quick thing is to use the AI model. You probably want to use the uh, Fermion Cloud GPU. So if you type Fermion help, spin help, here you'll see the Cloud GPU plugin. So you can just add a plugin using like spin plugins list, and here you'll see that Cloud GPU plugin is installed. So you can just add it after the list in the list. So you can add this to your one of the spin commands, and then you can say spin uh, Cloud GPU init, and this will initialize a GPU instance. You do have to have a Fermion Cloud account, and then it will generate the necessary details, the key and everything, which you have to store it in a runtime config.toml file, and you do have to substitute the the URL that is in your cloud account and put it in this file. And then whenever you do spin up here, I get to runtime config.toml, you have to pass it to through the runtime uh, config file flag, and then you can access the Fermion Cloud GPU and see the output of your LLM models. So it is much faster than doing it locally. So I highly recommend doing that. Now let's just see the uh, generated trip. Yeah, hopefully it works. We do have to do a few more things, but at least just to see some feedback and if you're doing it properly, I will use the Perl script that was given with the challenge here. So this one, and yeah, let's just go there. Okay, the Perl script is here. So now I have to do spin build to see if my code is error free. It's not. Oh. Let's go to Carver Tunnel. I think this is maybe not required. Let's see. Okay, perfect. Let's see if it builds without any errors, or hopefully without any errors. Okay. Ah, sorry, some typos here. Oh, wait. Wait. Sorry. Oh, I just forget the syntax. Okay. Perfect. Okay. Um, oh yeah. Oh, now I have an unwrap here. Okay. Unexpected token. Hmm, let's see where this is. Oh, okay. Okay, perfect. Now let's see spin out and pass the file and test it using our Perl script that we have. It should not pass, at least it is expected to fail. But there you go. So it does generate an itinerary. Let's kind of zoom in here. Uh, so it says, so the input that we gave was weekend ban, uh, destination is banned, fund duration is 1 week, 4 people, and the activities we were kind of planning to do is hiking, camping, long drive, and food. Let's see what it generated. It says experience and relaxation. Day one is arrival in Banff, drive from Calgary to Banff, 1.5 hours. Okay. That even tells the time. Check in at a hotel or lodging in Banff, explore the town, Banff and its shops, cafes, and restaurants. This is pretty good. This is more than what I was expecting. So it at least is able to understand the prompt and give a response that makes sense, which is a good start. Now, to actually pass the test that we have, because we're just expecting instead of a raw text, we kind of expecting a JSON string, and that should have itinerary field in it. So to do that, we'll just have to uh, put this generated itinerary into a format that is more appropriate. And also we have to generate the tag to store it in a key value store. So to start the key value store, we should just uh, start it with the store default, sorry, not delete, uh, default, open default. And then this will kind of open us the store to kind of put our values. And to generate the tag, we do have to create a tag, say like let generated tag equal to, we are using the random string create, and let's use generate, and length is probably like 6, and cache set is, let's just keep a few letters and numbers, and it will generate a random uh, string out of it, which is pretty useful. And yeah, now that we have a string, we can pass it, we can store it in the key value store. So let's see how, just looking through the documentation here real quick. Okay. Okay. So yeah, we do have it. So to set the, so we just have to do store.set, and key is the generated key, and value is uh, generated itinerary. And yeah, we have to make sure if it's saving or not. And let's quickly put this here and see if it stores. We'll just print data saved successfully. Uh, else print error saving data. Save. This will make sure. Okay, let's see the error here. Okay, it's a string, so we have to convert into bytes. See as bytes. Okay, so probably do the trick. Okay, now we are able to kind of store the input, the generated itinerary and the random tag in the key value store. Now we have to send it back to the user. Instead of sending hello fermion, now we have to send the actual uh, uh, data that we have. So to do that, we just have to create a response body, and let's see. Mm, so JSON uh, uh, string. Okay, we have to input a JSON object with itinerary and generated itinerary, and let's see, tag as generated tag. Oh, sorry, it repeated generated tag. Okay, close this. Let's see. Okay, now that's the response body, and we can give it to the body here. What's the error here? Let me see. Wait, let's see the documentation for. Okay. Um, um, leftover tokens. Very well. Sorry. Okay, I actually didn't put it in JSON format. That's my bad. Okay, now it should be good. Yeah, now it should at least pass the first test that we have. Let's do spin build and spin up. All right, let's see if it runs at least one of the tests, if it passes or fails. Okay. Okay, let's see what's the error. I think it's the second one. The first one actually. Yeah, yeah. I think it's the second one that fails. We haven't gotten to this part yet. At least one of it is passes. One of the test passes. Now to actually store it, now that we stored it, we also have to retrieve it. And to do that, we kind of have to pass the tag that is generated in the route, and we have to kind of capture that. So to do that, we can, uh, before going into the code, we can just capture the path here and save it. Request or path. Let's see. Path is a string, and then we do have a prefix that we have to consider. That is, let's see. plan my trip. That's the prefix. So we will have to use any route that is on top of it. So let's include that here. Okay. Let's see. Given tag by the user. We'll have to kind of path dot. Oh, let's say our first path here. Quest path dot. Um, why isn't this working? Straight prefix, and we have to take the prefix out. If, yeah, let's see. Okay, strip prefix exists. Okay. Now that we got the given tag by the user, we have to see if this tag is in the code or not, in the KV store or not. So for that, we can say if store.get of given tag is stored itinerary. If it is obtained, let's say we're not able to find the tag. Okay, sweet. Store.get. Okay. And now that we obtained the itinerary, we have to again return it back to the user. So copy the whole thing here, and we have to return it early right here. Once that we found a object, so instead of generator, we'll say stored and event tag, and here we are testing 200 and response body. Return this. Okay. I think this captures the case when the user sends a itinerary, and for that we do need to have a tag. Let's just print the tag here as well, so that we can we can test it better. So generator tag is okay. Oops. Okay. think this handles that case as well. Now let's build and see if there are any errors. No errors, and then let's run our code. All right. First, let's run the test. One, it should fail because we haven't had any tag to retrieve from. So it should generate some kind of itinerary here, and we should be able to. Okay, the generator tag is WF32IR. That's the unique tag for this specific itinerary. That is tour sightseeing. The thing that we saw. Okay, there's also hike at a sulfur mountain. Just pretty specific. Okay, let's test here in our test.hull script. Instead of this, let's put the uh, tag that is generated. And yeah, let's test it again. This time, hopefully it should pass. Let's see. Okay. As you can see, both the tests have been passed, and we can see in the logs here that data is saved successfully. The tag generated is uh, this one, and the generator itinerary is this one. So uh, the tests are passing, and we are able to save it. Of course, the code is not the structure really well, but at least it does the job. I do already uh, created a repository and upload. I will upload all this there so that you can refer to it later. But this basically covers the challenge. You can also deploy it into your spin deploy, and you can deploy it into Fermion Cloud, and you can access this. You can test it instead of local host. You can test it using your Fermion Cloud link URL. And yeah, thank you very much for joining me in this walkthrough, and hope you had fun trying this challenge, and hope you try to solve the future challenges that we have.